Let's review more examples of radical and exponential expressions. Let's take, for example, the 6th root of a and put that into exponent form. That would be a to the 1/6 power, where 1 was our exponent of a and 6 is the root. Let's try another one. Write the radical expression that is equivalent to, let's say, x to the 3/4. So that's an exponent form, and we want to put that in radical form. So the root would be 4, and the radicand is x, and the exponent is 3. So once again, whatever is in our numerator, that is the exponent. The 4 is our root, it's in our denominator, and x, which is the base, becomes our radicand. Let's try another. How about let's rewrite the expression x to the 1/6 over x. Well, let's use our quotients property of exponents and rewrite this as x to the 1/6. And really this is technically a 1, x raised to the first power in the denominator. So I'm going to bring that upstairs and change that to a -1. Then, using the product of powers with the same base, I know that I can add my exponents. So it becomes x to the 1/6 minus 1, which is equivalent to x to the 1/6 minus 6/6, which simplifies to x to the -5/6. Now, if I was asked to put that in using only positive exponents, I would need to rewrite that as 1 over x to the 5/6. Let's try another problem. How about a to the 5th power multiplied by a to the -1/2 power? Now, I recognize right away that I have the same base, so I can use the product of powers with the same base, and I can add my exponents. So I'd have a to the 5th plus this -1/2, which results in a to the 10/2 minus 1/2, which is equivalent to a to the 9/2. If I was asked to further put that into radical form, it would become the square root of a to the 9th power. Let's try another example. How about y to the -1/3 raised to the 4th power? Using the power of power property, I can multiply my exponents, so it becomes y to the -1/3 multiplied by the exponent of 4 over 1, which is equivalent to y to the -4/3. Now, if I was asked to put that into a form using only positive exponents, that would become 1 over y to the 4/3. Let's try another example. How about 6 multiplied by b cubed over 2 multiplied by the 4th root of b? So let's go ahead and begin this with breaking this up. So this becomes really 6 over 2 multiplied by b cubed over b to the 1/4. Using the quotient property, this becomes 3 multiplied by b cubed times b to the -1/4. Now, using the product of powers with the same base property, I can add my exponents. So it becomes 3 multiplied by b cubed plus a -1/4, which becomes 3 multiplied by 12/4 minus 1/4, which results in 3b to the 11/4 power. Well, let's try one last problem. How about the problem of x to the 5 6 multiplied by x to the negative 1? And let's say the problem was asking to express this in the form of x to the nth power. So I want the form of x to the nth power. Let's begin by writing this as x to the 5 6 multiplied by x to the negative 1 raised to the 1/2 power. Now, using the product of powers with the same base, I'm going to combine my exponents there. I'm going to add them. So I have 5 6 plus a negative 1, and that whole expression is still raised to the 1/2 power. So that simplifies to x to the negative 1 6 raised to the 1/2 power. Now, using the power to powers property, I would multiply my exponents. So a negative 1 6 raised to the 1/2, I can multiply that, and that becomes x to the negative 1 12.